Now, for today's lesson, okay, again, okay, yesterday, okay, we took about roughly about 1 hour or less than 1 hour, okay, to cover one question, okay. So that is actually, I just wanted to give you an example of how difficult question 3 can be, okay. So that's going to be, but not all the situation we will have that kind of question, okay. So uh, earlier in the morning yesterday, I gave you a very easy question. Okay, in the afternoon or in the evening, I gave you a very difficult question. So today, okay, I'm going to actually also show you. Okay, not all the time is going to be a very difficult question. Sometimes, okay, the notes, okay, the notes that they have provided to you, okay, in the question paper, which is qualitative analysis notes, will be very useful to answer the question. And this is one of the example of the question that can actually be like that. Okay, this paper is actually also from last year paper, but it's going to be I think May-June paper. Okay, May-June paper, and the code is 33, which is the same code as what you are going to see. Okay, so this is a very easy question. Okay, take note again, paper 3. It is a 2-hour paper, and then it has 3 questions. Okay, so we are not actually going to look at the first 2 questions, but I'm going to look at the qualitative analysis part, which is question number 3. Now, so if you look over here, I think you can see, okay, in the beginning, from here all the way to here, the instruction is almost the same as the one that we have discussed previously. But here we have FA4, okay, for a change, okay, I have given all the information at the back of this worksheet, okay, but for a change, let's actually look at without knowing FA4, okay. I will actually give you some of the information, and then you are going to help me to deduce what might be FA4. Okay, so FA4 they have mentioned it contains a single cation and a single anion. Okay, the anion they said, okay, it might be either sulfate or sulfide. So what I did was, okay, I just immediately go to my notes over here and just look at the sulfate and sulfide. Okay, so I actually took that and copied over here and put it over here. Okay, so this is going to be where the notes is going to be very helpful. Okay, so here they say that to approximately 1 cm depth of Fa4, okay, add aqueous sodium carbonate. Now this one they say just barium and then strong acid and so on. It means we haven't used that yet. Okay, but here what they ask you, okay, you have Fa4, okay, you are going to actually add sodium carbonate. Now when you have sodium carbonate, and then you need to actually record your observation. Now when you record the observation, it means let's say imagine you're doing the test now. When you add, okay, the sodium carbonate into Fa4, what happened? You saw, let's say imagine you saw gas is being released. Okay, when gas is being released, okay, how do you write it over here, Kenneth? How do you write your observation? You did see gas, so Kenneth, hurry up, let's not waste time. Unmute your microphone, Kenneth. Yeah. So if Kenneth is not here, maybe we'll actually check with someone else. Maybe Alvin.
The test, sir, for the gas.
Yeah. No. You saw gas. So how do you actually record your observation? How do I answer over here when you saw gas? Do you write gas is released?
Effervescence.
Yes. Okay. You write effervescence is seen. Okay. Effervescence is seen. Okay. And then when you see effervescence and you see it's sodium carbonate, and you have a gas, what might you expect over here? What test will you conduct? What kind of gas that you are going to suspect over here, Alvin?
CO2.
Yeah, most likely it will be CO2. So what test I will use? I'm going to test with, when tested with
Lime water.
Yeah, so it's a good test. Okay, when tested with lime water. Okay, this one I'm going to actually, let's say imagine you are testing with lime water, and then you found out the lime water turns into milky. Okay, the lime water turns milky or cloudy. Okay, now, so what you know now is, okay, you confirm that it's going to be carbon dioxide is being released. Now, when carbon dioxide is being released, when you test with sodium carbonate react with what gives you carbon dioxide? Elisa, sodium carbonate react with what will give you carbon dioxide? Okay, let's not waste time. Okay, Wesley, sodium carbonate react with what gives you carbon dioxide?
Acid ya.
Yeah. So most likely, okay, most likely we are dealing with acid. Okay, most likely it's going to be dealing with acid. And then it might be any acid that involves sulfate, might be sulfuric acid, might be this H2SO3. Okay, so it might be acid. Definitely going to be acid because sodium carbonate, okay, they will give you carbon dioxide when it is heated or when they are tested with acid. Okay, so it's a very good indication over here. Now we know it's going to be acid. Let's actually further confirm. Okay, so I know roughly it's going to be H plus. My cation is H plus. Now let's look at the anion now. Now the anion, okay, select region to identify the anion present in Fa4 because we are looking for anion. So just now, they mentioned that it might be either sulfate or sulfide. Okay, so here, looking over here, if they ask you to suggest, okay, if they ask you to suggest the region, okay, what might be the region that you will suggest? Clear?
Yes, sir.
Yeah, what will be the region that you will use to differentiate sulfate and sulfide or to identify whether this thing is sulfate or sulfide? Can you see here, barium 2 plus, and then they say dilute strong acid, dilute strong acid. So can you suggest a solution that contains barium 2 plus and dilute strong acid? What will you
Barium
suggest?
hydroxide.
I will suggest, okay, to use barium nitrate because barium hydroxide is going to be insoluble. Okay, so all nitrates are soluble. Okay, take note of that. Is that clear, guys? Okay, barium nitrate. Okay, you can also use barium chloride. Okay, barium chloride or barium nitrate. Okay, and then let's say now you are using the strong acid. What might be the strong acid that you will be suitable to be used over here? Chelsea, suggest a strong acid. Dilute what? Hurry up, let's not waste time.
Hydrogen chloride.
Yeah, okay, it means hydrochloric acid. Hydrochloric acid. Now, you maybe in the first let's say when I was doing this question, I was actually thinking a strong acid. Okay, strong acid. There's so many strong acid. I have nitric acid. I have sulfuric acid. I have hydrochloric acid. First thing that came into my mind was sulfuric acid. Now, can you suggest why I didn't actually use sulfuric acid? Why I selected ACl rather than sulfuric acid? This is my answer actually. Okay, I'm going to use dilute ACl and I'm going to use barium nitrate solution. Okay, but why I didn't use sulfuric acid? Joshi? Hurry up, hurry up. Why I didn't use sulfuric acid? Okay, let's select someone else. Helen, why I didn't use sulfuric acid?
Don't know, sir.
Can you see here, SO4? Okay. Now, if you have SO4 and SO3, okay, if you have a single anion, it means let's say the anion is sulfate. Okay, if I just go and put sulfate over there, okay, it might actually, I might not get the result that I want. Okay, I might not get the result what I want. So I try to avoid because if I'm actually taking that acid, because I'm predicting it might be sulfuric acid, my Fa4, I'm predicting it might be sulfuric acid, or it can be H2SO3. Why I want to actually use the same region to be added over here? Can you understand this part? So I don't want to use the sulfuric acid. So I try to use something that is different than SO4. So I'm using HCl. You want, you can actually use HNO3. Okay, so basically, the observation, okay, the observation that you will see over here, okay, you will see, okay, this is the actual observation when you do the practical. You will see there is going to be a white precipitate will be formed, and then when you add excess acid, okay, when you use excess acid, okay, which is going to be HCl, okay, the precipitate, the white precipitate is insoluble, okay, insoluble, so it remains there. Now, using this observation, can you predict to for me what might be the anion? White precipitate, insoluble in excess. Stacy Setiadi, can you help me to predict? White precipitate, insoluble in excess. No response. Gwen? White precipitate, insoluble in excess? Yeah, sulfate. Okay, you can see over here. So that's going to be the sulfate. It means you're already confirmed it's going to be SO4 2 minus. And just now we have confirmed it's going to be H plus. So the formula of Fa4 is H and H plus and SO4 2 minus. So we are looking at H2SO4, sulfuric acid. Okay, this is considered to be easy, yeah. Okay, take note. Okay. Now, let's actually move on for the part B. Okay, for part B, they have this question saying that FA5, okay, FA5, let's actually keep it let's say we do not know what is FA5. I will actually guide you through, okay. It contains one cation and two anions, okay. One cation, but two anions, okay. Take note of this. Two of these ions, okay, two of these ions are listed in qualitative analysis notes. It means, okay, they have three ions over here. Only two of them listed in your notes. One is not in your notes, and I don't think so they will ask you to find what is that, okay? So here, okay, so here, even when they ask the question, they say, find out what is cation and one of the anion. Okay, one of the anions. So they only ask the one that is inside your notes. Okay, so first thing, what they actually put over there, they say you take the Fa5 and then you are going to heat, okay, Fa5. Okay, now when you heat up, okay, I will actually explain what you might see. Okay, when I heat up, okay, the powder, okay, the Fa5, okay, start to turn black. Okay, it start to turn black, and then the tube, okay, the end of the tube, you are going to see droplets of water, okay, like water droplets being formed at the end of the tube. And you saw some kind of a gas, okay, but it's not effervescence, like it's not bubbling and suddenly give you gas. It's just gas, like a white fume, most likely because there's a formation of this water droplets. I'm assuming, or you are going to assume, it's a white fume. So white fume, I'm assuming it's going to be water or steam. Okay, I'm assuming it might be steam. So here, I didn't do any tests for the gas. Okay, I didn't do any tests of the gas. But if you want to do tests also, you can write it down. Okay, but in this case, I didn't do any tests of the gas. So basically I saw it's going to be black and then it become wet. Okay, so the solid become black and then it became wet. So here I still do not know what might be my cation, what might be the anion, but I can roughly guess. Okay, if you look at the cation, okay, when you heat up something, of course, okay, the cation will change into oxide. So it means you will get aluminum oxide, ammonium oxide, there's barium oxide, calcium oxide, and so on. Out of all these oxide, can you tell me, if you know, okay, what is black oxide? Have you actually seen any, or heard any black oxide from this list? Nadine?
I don't know, sir.
Don't know. Shirley? Black oxide.
Copper oxide.
Yes, good, good. So copper oxide is black. So if you know that information, okay, take note that it's not inside these notes, but if you know this observation or if you know this information, you can actually just say that it's going to be copper 2 plus. Okay, if you know that, okay, so that's why it's very important. Okay, but if you do not know, let's just put it, you don't know. But I know the black might be copper oxide. Okay, I know it's copper oxide. Now, again, okay, take note, there is going to be some kind of wet, okay, it means some kind of water is being given off, okay, so take note, water is given off when you heat up Fa5, okay. So here, I'm suspecting it might be copper, but something that can give me water, okay, something that can give me water. Now, after that, I'm going to actually use sulfuric acid, okay, and then I'm going to add, okay, to Fa5, and then I'm going to let it to complete, and then you are going to actually get the Fa6. Okay, so the moment I add, okay, the sulfuric acid, I'm going to get some sulfate. So if you know copper, okay, so most likely it's copper sulfate. Okay, if you know earlier. Okay, but let's say you do not know. Let's say you do not know. What I saw, okay, when I do the test, I will see, okay, a blue solution, okay, is being formed. Okay, I see a blue solution being formed. And I saw gas. So again, when you see gas, okay, you do not write down gas is being released. You write down, in this case, it's going to be bubbles. So effervescence will be seen. Okay, effervescence. Okay, effervescence will be seen. Okay, so you do get a blue solution. Now, if you do not know that is copper earlier, if you look over here, what actually might give you a blue solution? I think generally here will give you some kind of idea. Blue, okay? So there's only one over here that is going to be blue, okay? Most likely is copper. So when I see over here, okay, I know, okay, this is confirmed going to be copper, okay? It's going to be copper. So I know it's going to be copper. And when I have effervescence, okay, I'm going to test for what gas. This is very important, okay? I'll ask again, Elvin. Elvin, you do have effervescence over here. What kind of gas do you think might be here?
I don't know, sir.
Okay, just take note. You are adding sulfuric acid. Okay, you are adding sulfuric acid. You are not going to get, okay, you are not going to get sulfur dioxide, okay? Or you can always check over here, what when you add acid gives you gas. So you can see here, there's only one when you give add acid gives you gas. The rest is adding OH, okay? So most likely it's going to be carbonate. And then I'm still not sure, okay? I'm still not sure, okay? So what I need to do, I need to double check. So when I check, I still need to test using what? Lime water. You do not actually test using lighted wooden spoon. Okay, this is you need to plan. Okay, you test using lime water, and then when you test, let's say you happen to test, when you test, it became cloudy. Okay, I'm giving you answer over here. It became cloudy. Now, when it became cloudy, basically it's carbon dioxide. So what can you say, okay, about the anion in Fa5? Elvin? We only
CO3
have
2
six.
minus.
Yeah. Yes, it's most likely CO3 2 minus, most likely. Okay, but we need to still confirm. Okay, further test is being done. Okay, so here, okay, you are taking Fa6. Now, Fa6 is already you are adding copper. We are suspecting it might be copper carbonate. Yeah, we are suspecting it might be copper carbonate, but they are using Fa6, copper carbonate plus sulfuric acid. Okay, will give you copper sulfate plus carbon dioxide. The carbon dioxide is tested over here, plus water. Okay, or for example, if you have copper carbonate, when you heat up, it will give you copper oxide, which is black, copper and carbon dioxide. Okay, carbon dioxide. So it's going to be okay. Basically, when you heat up, it's going to actually give you water also. But never mind. So, okay, so for now, okay, if you look over here, okay, you are going to actually do further testing. When you actually add aqueous sodium hydroxide to copper sulfate now, Fa6, yeah. So copper sulfate, you are going to test. It will give you a pale blue solution insoluble in excess. So if you look over here, okay, you are going to do the test and you found out it's pale blue precipitate. When I add sodium hydroxide, it is insoluble in excess. So it's further going to confirm it's copper 2 plus. So I know it's going to be copper 2 plus. And then they did further testing. Okay, they asked you to add aqueous ammonia. What you will do, okay, when you add, you saw a blue precipitate. And the blue precipitate, I will write down here, blue precipitate, you see blue precipitate, but it's soluble to give you a deep blue solution in excess, okay, in excess. So once you do this, it's going to be confirmed, it's going to be Cu2 plus. Okay, basically this notes is going to help you 100% to reach that answer. Okay, so we finally found out it's going to be copper carbonate. Okay, so state the type of reaction, okay, observed when Fa5 was heated. So here, when you heat up, okay, copper carbonate, you are going to get copper oxide plus carbon dioxide. But I do not know what might be some other ions might be there that makes my tube become wet over here. So I'm still getting the mark for writing it going to be black. But if you look at the marking key, okay, the marking key, they actually wrote, okay, the solid turns black. Okay, and then they also give answer where the steam is going to be released or the tube will become wet. Okay, these two, okay, you will get the mark. If you just mention it's going to be black, you will get only 1 mark. Okay, but sometimes we cannot avoid it. If you just write 1, okay, we miss out this, okay, we cannot avoid it. Okay, so you just take note. Okay, but doesn't matter. Okay, we try to get as many marks as possible. Okay, further here, state the type of reaction observed when Fa5 was heated. Okay, this one is going to be what we call as thermal decomposition. And give the formula. Okay, let's actually not waste more time. The one of the cation, this is copper 2 plus, and then the anion is going to be CO3 2 minus. Okay, that's it. Is that clear, everyone?
Yes, sir.
So
Yes.
still 2 more minutes left. But again, okay, you see, you can clearly see, okay, at least maybe if you still don't understand, if you compare to yesterday's lesson and today's lesson, probably today you will notice that this is easy. I can understand more. Yesterday was, I do not know what's happening. It tend to happen, okay, like that. Okay, sometimes, okay, I told you the notes are going to be very helpful. Sometimes, okay, it can be totally useless. Okay, so that's why you still need to practice a lot. Okay, we still need to do a lot of practice. Okay, like I think in the previous question they have tested related to nitrate and nitrite. Okay, uh, today we saw they tested on sulfate and sulfide. They tested using carbonate. Okay, this one I think most of the time they will actually test you. Okay, maybe if we have an opportunity, we will actually check also involving these 3 as well. Okay, so that's why I'm actually going through the latest practical so that you can actually get used to the questions, and then we can actually try to anticipate. Now the over here, the aim is not to actually answer everything correctly. The aim is, okay, is to make sure that you can plan your experiment properly. It means you need to anticipate. Okay, this word is very, very important. Anticipate. Okay, you need to actually identify what might be given off, and then you do the test accordingly. So all these are involved in the planning. Okay, this one of course I don't plan. I just heat up. Okay, I saw it's black. I don't know whether it's going to give me carbon dioxide also or something like that. I didn't test for carbon dioxide. But here, okay, I know, okay, it might be giving me carbon dioxide. So let's test for carbon dioxide. So I test. So this is important. Okay, you need to anticipate what you need to do. Okay, I know it's going to give me a pale blue solution or a pale blue precipitate, but I need to add it to excess, and then I need to make sure it's going to be insoluble or not. So how am I going to actually find out that? So I need to anticipate all this. Okay, that's very important. Okay, so it's already 9. Okay, I will end this lesson. Later, I will actually put the video for yesterday and today. Okay, and then I will also send you the work version of this worksheet as well. This one need to be submitted to me, okay, by 6 p.m. So I actually put the deadline at 6 p.m. today. Okay, that's all, guys. Thank you.
Yes, sir.
Yeah.
Bye,
Thank
sir. Thank
you.
you, sir.
Yeah, we have class at 5 also. Yeah, see you. Bye.